So here's what we're going to learn how to do today. We're going to learn how to take some basic probabilities. We're going to learn how to do some compound events with like and or statements. And we're going to learn how to use these two-way tables to make a Venn diagram. So the first thing I'm going to do is I'm going to make a Venn diagram off this two-way table. And let's give us some events. So let's say A is the event that I have a person that is in hospital A. And let's say S is the event that that person survived. Okay, so the first thing I'm going to do is I'm going to make a Venn diagram. Now the most important thing is when you make a Venn diagram, you want to include all the space. You want to have like the entire sample space. And so we'll make, let's do my purple circle as A, and let's do my green circle as survived. So, and if we do this, we would find that the amount of overlap is, if you attended hospital A, there's 237 people right here that were both in hospital A and then survived, which means the other people that were in hospital A were the 63 people that died, and then the other people that survived would have been in hospital B, or which would be this number of 784. So all the people that were not in hospital A and died would have been these 16 people. So now I have all, if you add this up, I have my total number of people. So every single one of these bubbles will add up to my 2,900. So there's a couple probability things that we can do off this. Let's first look at the probability that somebody is not in A. And how I would show that somebody is not in A would be this little C right here. That C means it's its complement. So that little C means it's its complement, telling you that we do not want something in A. So everything that would not be in A would be this 784 and this 16. So out of all 2,900 people, the people that would not be in A would be 784 plus 16, which I believe should give me 800. So there would be 800 people that would not be in A. And you could also see this as that's all the people that would be in hospital B. So that's where we can get the 800. Let's do something that's a little bit trickier. Let's find the probability that something is in A and it's not in B, or it's not in S. Whoops. Using the wrong kind of letters here. So it's not in S. Rewrite that. So, again, that little C is going to tell me it's not an S. And so that would be all the people that are not in A, or are in A, but are not in S, which would just be these people right here. So that would be 63 over 2,900. Okay. Let's do one more tricky one. Let's take this probability. So let's do the probability that they are not in A or they are not in S. So they are not in A or they are not in S. This one is pretty tricky if you think about it, because in or statements it kind of means either or is true. So it not being in A would actually include these 784 people, because those 784 people are not in A. It would also include this 63 people because those 63 people are not in S. So when it's an OR statement, either or could be true. So it includes the 784, the 63, and it's going to include the 16. So it's essentially, if you say something is not an A or not an S, it's going to be everything except where both those things are true, which is where they're both an A and S. So we would take 63 plus 784 plus 16, and we're going to just do that really fast. So 784 plus 63 plus 16. So that would be 863. So hopefully you're getting a good idea of how you figure out like what these knots are. Again, this shape will mean and. It's called an intersection. It means and. This one's a union. It means or. So hopefully you're getting some of those symbols down. You understand that the C means not, and you understand how you take things from this table over here and put them into a Venn diagram. So I have quite a few examples on Canvas. You're going to round kind of all of them to the different percents and just try the different problems in your group.